Hello, everybody. Today we're going to review or go over lesson 6.4, Common Denominators. And basically our essential question is, how can we write a pair of fractions as fractions with a common denominator? That's going to be an important skill for us to have for adding and subtracting fractions. So let's unlock the problem. You're going to need two pieces of paper for this activity. And Martin has two rectangles that are the same size. One rectangle is cut into half-size parts, and the other rectangle is cut into one-third size parts. He wants to cut the rectangles so they have the same size parts. How can he cut each rectangle? So he has a half-size part and one-third size parts. And he wants to cut the rectangles so they have the same size parts. So you see the model here. This represents our two pieces of paper. Okay. So a common denominator, one of them is a half and the other is broken into thirds. So a common denominator is a common multiple of the denominators of two or more fractions. Fractions with common denominators represent wholes cut into the same number of parts. Okay, so we're going to find a common denominator for 1/2 and 1/3 using an idea of paper folding and shading. So step 1, model the rectangle cut into half-size parts. So fold one sheet of paper in half. Okay, that's simple enough, right? So make sure that we have the edges lined up. We want to make it as even as possible. Crease the paper, open it back up, and draw a line on the fold. Okay. So we've drawn a line on the fold. Okay. Step 2, model the rectangle cut into 1/3 size parts. Fold the other sheet of paper into thirds. So let's look at this. We need our paper to look like that. So let's divide our paper in half 3 ways. Not in half. Fold your paper into thirds. Crease it. Okay, let's open it back up, and let's put lines on the two folds. Okay. All right. So we've modeled our two fractions. We have 1/2 and we have 1/3. Okay. So what's our next step? So after we've done that, it says fold each sheet of paper so that both sheets have the same number of parts. Draw lines on the folds. How many equal parts does each sheet have? Okay, well, the one that has the thirds and one that has half. What would happen if we folded this one into thirds? So it had the same pieces as this, right? And what if we fold this one in half to match this one, to match the one with half? So let's see what would happen if we folded it in half. Okay, so we took the paper that was folded in thirds and we folded it in half so it matches the fold of the other piece of paper. All right, and so now I look at it, now I have 6 sections, 6 equal parts. Well, this part still only has 2. Well, what happens if I take the paper with 2 parts and fold it so it has 3 more parts? If we open it up and draw lines along the folds, we've now made 6 equal parts on this piece of paper. So now both of the papers match. And so that's what we're looking at with common denominators. So we went with 3 pieces and turned it into 6 equal pieces. We went from 2 pieces to turn it into 6 pieces. So, looking at our question, how many equal parts does each sheet of paper have? Well, 6, right? So draw a picture of your sheets of paper to show how many parts each rectangle could have. Okay, so if we have rectangles, right? And we had another one that matches it. Okay. So there's our 2 pieces of paper. One of them was divided in half. Well, that's not half, is it? Okay. Ignore that line. I should have done a better job. Okay, that's halfway. That's what I should have done to start with. Okay, so the red line represents the half. The other one was split into thirds. That's about thirds. All right, so that's what it should look like when we first folded it. We then took the one that had third size pieces and we divided it in half to get 6 pieces. The one with third size pieces, with half size pieces, we added 3 folds. So it still has 6 pieces. All right, so each rectangle can be cut into 6 parts. All right. Now, so that's one way you could find a common denominator. You can use paper folding and shading. That's a more lengthy process, but you can do that. Okay. Page 250. All right, so another example, we can write 4/5 and 1/2 as a pair of fractions with common denominators. And we can use common multiples to find a common denominator. This is a method that I prefer to use. And we're going to list multiples of each denominator. A common multiple can be used as a common denominator. Step 1, list the multiples of 5 and 2. So we're going to be using the denominators, which makes sense. We've got to find a common denominator. So 5, 10, 15, 20, 25, 30. Okay. And 2, 4, 6, 8, 10, 12, 14. Circle the common multiples. Well, the first common multiple I see is 10. All right, so what would I have to multiply 4/5 by to get tenths? 5 times 2, right? So also multiply the numerator by 2 to get 8 parts. So 4/5 is equal to 8 tenths. And 2 we have to multiply by 1, 1, 2, 3, 4, 5. So I have actually written these incorrectly. Let me go back and fix that for us. You notice here that they have 5, and then they listed the first multiple as 5, 10, 15, 20, 25, 30. Well, here the first multiple is 2, but I wrote the second multiple, so I need to move these all over slightly. So it should have been 2, 4, 6, 8, 10, and 12. The common multiple is still 10. I just wanted to be consistent with how we're listing the multiples. Okay, we're finding the common multiples of 5 and 2, and we're going to start with those two multiples as the first term, or the first multiple. Okay, so 5 times 2 is 10, and 5 times 1 is 5. So we can rewrite 4/5, 4/5 and 1/2 as 8 tenths and 5 tenths. Are those two fractions equivalent? Well, okay, so the denominators are the same, right? If you get 8 pieces out of 10 versus 5 pieces out of 10, are they the same? No. So they're not equivalent. No. 4/5 can be written as 8 tenths, and 1/2 can be written as 5 tenths. Eight tenths and 5 tenths are not equivalent. So 4/5 and 1/2 are not equivalent. Okay. So finding common denominator also helps us compare fractions. Okay. All right, now number 2. Describe another way you could tell whether 4/5 and 1/2 are equivalent. Well, if you look at the numerator and denominator of both of these fractions, 4/5. Well, those are, the 5 is prime, right? And 1/2, both the numerator and denominator are prime. So that means it's been reduced as far as it can go. 4 is not a factor of 5, so it's in simplest form. Well, if both these fractions are in simplest form, they should be the same fraction. So that's another way you can tell. So Number 1 on the share and show. So we should be able to do these. You should be able to do these independently at this point. So try to do these by yourself. If not, then obviously use the video. Find a common denominator for 1/3 and 1/12 by dividing each whole into the same number of parts. Use the models to help. Okay, well, this piece has 12 sections. This piece has 3 sections. Well, I see the horizontal lines on both of these papers. So this 12 has a section that's thirds. But then I also see it has 1, 2, 3 vertical lines. So what if I added 3 vertical lines to this one? Do I get 12 sections? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yes, I do. So 1/3 is the same as 4/12. Okay, so use the models to help. What's the common denominator? The common denominator is 12. Okay, let's go to page 251. All right, write a pair of fractions with common denominator. So you can list multiples or you can use folding. I'm going to use common multiples. So my denominators are 2 and 4. So I have to find a common multiple of 2 and 4. So I'm going to list the multiples of 2. 2, 4, 6, 8, 10, 12. 4. 4, 8, 12, 16, 20, 24. All right. Now, circle common multiples. Well, the 4 is in common. The 8 is in common. The 12 is in common. So which one do I choose? Well, go with the smallest. Okay, it's what we call the least common denominator. So 1/2, I would be multiplying by 2 over 2. 1/4, I don't change that at all. It's already fourths. Okay, so 1/2 times 2 2's is 2/4. So our equivalent fraction pair is 2/4 and 1/4. All right, 3. 3/4 and 5/8. So our denominators that we need to match are 4 and 8. So 4, 8, 12, 16, 20, 24, 8, 16, 24, 32, 40, 48. Well, I see that the least common multiple is 8. All right. Well, I probably could have stopped right at 8 then, huh? If I have to find the smallest one. So keep that in mind. 3/4 times 2 over 2 would turn it into eighths. So 6/8 and 5/8. All right. 1/3 and 1/4. So we're going to use thirds and fourths to find a common denominator. 3, 6, 9, 12, 15, 18. Let's list 6 factors of 4. 4, 8, 12, 16, 20, 24. So the 12s are in common. So what do I have to multiply 1/3 by to get 12? 1, 2, 3, 4. So 1/3 is the same as saying 4/12. 1/4, I'd have to multiply by 1, 2, 3. And I'd get 3/12. So we have 4/12 and 3/12. All right, 4/12 and 5/8. Well, we have to find a common denominator of 12 and 8. So let's list some factors of 12. 12, 24. 12 plus 12 is 24. 24 plus 12 is 36. 36 plus 12 is 48. 48 plus 12 is 60. And 60 plus 12 is 72. I forgot that the first multiple of 12 is 12. Okay, 8. 8, 16, 24, 32, 40, 48. All right, what's the first factor, first multiple that is in common? 24. All right, so 4 twelfths times what is 24? 1, 2. So 4 twelfths is the same as 8 24ths. 5 eighths times 1, 2, 3 is 15 24ths. So we have a common denominator of 8 24ths and 15 24ths. Okay, number 6. Write a pair of fractions as a pair of fractions with a common denominator. Okay, again, at this point, you should really be able to do these on your own. So 1/4 and 5/6. 4, 8, 12, 16, 20, 24, 6. 6, 12, 18, 24, 30, 36. Circle the smallest multiple, common multiple, 12. All right, 1/4 times 3 over 3 gives me 12, 3 twelfths. And 5/6 times 2 is 10 twelfths. So 3 twelfths and 10 twelfths. 3 fifths and 4 tenths. We're going to use 5 and 10. Okay, the first multiple of 5 is 5, and the next one is 10. Well, that matches 10, doesn't it? Okay, well, we can go ahead and stop there. So 3 fifths times what is tenths? 2. 2 times 5 is 10. So 3 times 2 is 6. So our pair of fractions with common denominators are 6 tenths and 4 tenths. All right, now we're going to tell if these are equal or not equal. So the first thing we're going to do is find a common denominator. Okay, that's one way we can do it. We can match up the denominator. We can also see that if they're in simplest form, they should match. Well, 3 is not a factor of 4, so that's in simplest form. 1/2 is in simplest form. They don't match. Okay, so that's not equal. If you wanted to prove it, we can go 1/2 times 2 over 2 to make it into fourths. 2 times 2 is 4. 2 times 1 is 2. 3/4 is not 2/4. Okay, so 3/4 and 6/8. What can I multiply 3/4 by to get eighths? So if I was finding a common denominator, I'd go 4, 8. Oh, well, that matches the other 8, right? So 3/4 times 2 over 2 is 6/8. 6/8 is 6/8. Equal. 1/2, 4/8. Here I'm going to use just reasoning. What's half of 8? 4. Okay, so 4/8 is 1/2. 6/8 and 4/8. The denominators are the same. If the denominators are the same, if they're equal, the numerators have to be the same. They're not. So that's not equal. 1/3 and 2/6. Well, let's find a common denominator. Let's start with the 3's. 3, 6, 9, 12, 15, 18. First multiple of 6 is 6. Well, they already match then, if I put 6. So 1/3 times 2 over 2 would turn the thirds into sixths. 2/6 matches 2/6, equal. Thirds and twelfths. 3, 6, 9, 12, 15, 18, 12. The first multiple of 12 is 12, and that matches the 12 in thirds. So multiply 1/3 by 4/4 to turn it into twelfths. 4/12 is 4/12. Those two fractions are equal. 2/6 and 4/12. Just list the multiples of 6. 6, 12, 18, 24, 30, 36. The first multiple of 12 is 12, so let's just use 12. 2/6 times 2/2 equals 4/12. 4/12 matches 4/12. Those two are equal. 4/12 does equal 4/12. Simple enough. All right, let's go to page 252. All right, Carrie has a red streamer that is 3/4 yard long and a blue streamer that is 5/6 yards long. She says the streamers are the same length. Does this make sense? Explain. All right. Well, so we're comparing 3/4 to 5/6. We can use common denominators to check to see if they're equivalent. I can also compare them with the idea that are they in simplest form, and if they're in simplest form, they should match. Well, 3/4, 3 is a prime number, and 3 is not a factor of 4, so 3/4 is in simplest form. 5 is also a prime number, and it is not a multiple. It is not a factor of 6. So 5/6 is in simplest form. Well, if they're both in simplest form, they should match, and they don't. Okay, so my initial thought is, yeah, they're not equal. Let's confirm it by finding common denominators. 4, 8, 12, 16, 20, 24. 6, 12. I'm going to stop there because they can both turn into twelfths. So 3/4 times 3/3 would be 9/12, and 5/6 times 2/2 would be 10/12. And again, they do not match. So no, it does not make sense. Three-fourths can be written as 9/12, and 5/6 can be written as 10/12. 9/12 and 10/12 are not equivalent. So 5/6 and 3/4 are not equivalent. Okay. No, it doesn't make sense. 3/4 can be written as 9/12, and 5/6 can be written as 10/12. Those two fractions are not the same. They're not equivalent. So that means 5/6 and 3/4 are not equivalent. 17. Leah has two same-sized rectangles divided into the same number of equal parts. One rectangle has 1/3 of the parts shaded, and the other has 2/5 of the parts shaded. What is the least number of parts into which both rectangles could be divided? Well, this one has 3 parts, folded in a sense. This one has 5. Well, if we multiply this third by 5s, and this one, this fifths by the thirds of this one, it would be 15. So 15 parts. What would that look like comparing the fractions and finding common denominator? 1/3 and 2/5. Well, what is a common denominator of 3 and 5? 3, 6, 9, 12, 15, 18. 5, 5, 10, 15. Okay, I can stop. I see a match. 15. Okay, so in a sense, we'd be multiplying 1/3 by 5/5, and we multiply 2/5 by 3/3. So again, just by looking at how many folds there were in one, this one had thirds. So if I then took those thirds and folded them 5 additional ways, I would have 15 parts. If I took the part that was in fifths and folded it 3 additional ways, I'd have 15 parts. Number 18. Julian says a common denominator for 3/4 and 2/5 is 9. What is Julian's error? All right. In my opinion, he added the fourths and the fifths. 4 plus 5 is 9, when he should have found a common multiple of 4 and 5. So 4 and 5, 4, 8, 12, 16, 20, 24, 5, 10, 15, 20. So the common denominator would have been 20. And 19. Miguel has 2 same-sized rectangles divided into the same number of equal parts. One rectangle has 2/3 parts shaded, and the other has 3/5 of the parts shaded. Into how many parts could each rectangle be divided? Show your work by sketching the rectangle. Okay, so we have 2/3 there. Okay, and the other one we have fifths. All right. And this one is 3/5. Okay, now if I add 5 sections to the 2/3, and I put 3 sections, add 3 sections to this one, 3 vertical sections, they would match. So let's do that. Okay, so 3, 6, 9, 12, 15. 3, 6, 9, 12, 15. So 15 parts. 2/3 is equal to 2, 4, 6, 8, 10/15. 3/5 is equal to 3/6/9/15. 2/3 can be changed into 10/15 by multiplying by 5. What did we do this one? We added 5 sections. 5 horizontal lines. We actually multiplied it by 5. The 3/5, okay, we had 3/5 going this way. We multiplied the 3/5 by 3. 1, 2, 3 to get 9/15. Okay, so that's it for lesson 6.4. Our next lesson in our next session will be lesson 6.5, problem solving, where we will work on problem solving and finding equivalent fractions. So until then, may the numbers always be in your favor.